Hello everyone, my name is Miss Shahbazi and I'm teaching advanced function in this session. I'm a math teacher for a long time. I'm teaching a math in different levels of high school. I know that during this time you are staying at home and is a good time that you can review whatever that you learned before and also learn a new stuff. Here we started, today is our fourth session for advanced function and we'll learn about the character of the polynomial function until this point and end behavior, the degree, and the way that it's like a turning point and the vertex point and so on. Today we are gonna continue our lesson for the polynomial function. Polynomial function is one of the like a most important subjects in advanced function because you learned it before like as a linear and quadratic function. Here you are learning more about the higher degree and we are gonna work on it more. The lessons that I'm gonna go over it is gonna be a sketching of polynomial function in higher degree. Let's start to do. Okay, it's before starting to go for the like a next lesson, I prefer to do these two questions as a fresh up, making sure that we know what we are doing it. Then we can go for the next question. I'm gonna just make it a little bit bigger that you can read. Oops. Okay, it's a polynomial function. Both shapes are polynomial function. This one, as we see that there is a two turning point, I am thinking has to be as a degree 3. Let's check. Yes, the ending hands at the positive infinity and negative infinity, they are following the opposite direction. It is a polynomial function and it is degree odd that at least it has a degree 3. I'm looking at another question here, another shape here. Again, the hands are going in opposite direction. Then it is a uh, sorry, it is a odd degree function. And let's see how many turning point do we have. 1, 2, 3, 4. I'm expecting this equation having a degree 5 because there's a 4 degree. Let's see if we can answer the question that we have here. I'm doing it. You can do by yourself. See how much did you learn from the past. Domain, it's a polynomial function. Always is x is element of real number. Range, same things. Sorry, for both of them, I'm gonna do both question in the same time. Now about the range. Range for this function, because it's starting from the down going up, is gonna be y, again element of real number. You can write it down as an interval from positive infinity to negative infinity. Look like that. Same for the other side, it's gonna be a range, same things. I'm so sorry. Look like that I have a problem in my notepad. I prefer to close the app and open it again. I'm so sorry. Hopefully the problem solved. Here, okay, it's gonna be look like better. Range, same thing here. Okay, number of roots. Number of roots, another name is x-intercept. Yes, 1, 2, 3. I have a 3 roots. And what are the roots? It's negative 3 here. And then I have a 1 and 2. Here number of roots is 1, 2, and 3. It look like negative 3. I know that it doesn't look like it's exactly passing negative 2, but here we are not writing equation of a function, then I can assume that's a negative 2 and negative 1, or maybe I can write it down negative because I do not know what is exactly the point. Roughly I can write it down. And behavior, I can write it down based on a Q, or when x is going positive infinity, y is going to the positive infinity in that case, and here y is going to negative infinity. For the other question, I prefer to use a Q to have both equations. Here is a quadrant 1, quadrant 2, and quadrant 3, and quadrant 4. Then if I like to write it down, and behavior here is gonna be Q2 to Q4 is another way for writing end behavior. Okay, what is the degree of function? We talked about it. Degree of function is 3. Name is cubic. Here the degree of function, as I said, is gonna be 5. Quintic. Okay. Interval of positive. We need to have a graph here. Interval of positive is gonna be, as you see here, I'm just showing the graph. For the positive is gonna be between negative 3 and 1 and bigger than 2. Interval of negative is going to be x less than negative 3 and between 1 and 2. Here, interval of positive, x is less than negative 3 and between negative 2 and 1. Here also I want to write it down in another way. For the positive, I'm trying just to have all of the way that we can write it down. For positive, I can write it down negative infinity and negative 3 and negative 2 and negative 1. There are the two different ways that we can write it down, the intervals. Now I'm talking about the interval of negative is gonna be, as you see, between negative 3 and negative 2 and 4. And negative infinity to positive infinity. Next question, interval of increasing. Increasing, when I'm checking it, is gonna be from negative infinity to 1.5 negative, and from 1.5 positive to positive infinity. Then it's gonna be x less than negative 1.5 and x bigger than 1.5. For sure, decreasing is gonna be between these two. How about here? We have a more increasing and decreasing interval here. Increasing is gonna be between negative 2.5 to negative 1.5 and 0 to 1. I have a 2 increasing and 3 decreasing interval. For increasing negative 2.5 and negative, and the other one was 0 to 1. Yeah. For decreasing negative infinity to negative 2.5 and negative 1.5 to 0 and 1 to positive infinity. Make sure that all of your brackets are open bracket, because not in any like a turning point are not increasing or decreasing interval parts. Good. Now there's a, instead of doing this warm-up question, I prefer to do the question that we did it together. Now I'm gonna just skip this one and start with actual sketching of, or maybe we can do this short answer like for the maximum or minimum. Okay, let's do it. Hopefully that you can see. I'm just making it a little bit bigger. Okay, here in this function we have an absolute maximum. An absolute maximum is here. Then the coordinate is gonna be negative 5 and 4. Absolute minimum. This function, both hands are, oh, okay. Here I have, it doesn't go for infinity, it is stop here. Then negative 8 and negative 8 is gonna be my absolute minimum, because the lowest point of my function. Local maximum. This point here, 3 and 1, is a local maximum. Local minimum. Local minimum, one of them is 0, 0, and the other one is 6 and negative 7. Interval of increasing. Here I have a two interval of increasing. One of them is negative 8 to negative 5, and the other one is 0 to 3. From here to here is increasing, and here is increasing. For decreasing, it's gonna be the rest of function, means that negative 5 and 0 and 3 to 6. Okay, here we are starting the equation and graphing of a polynomial function. We learn about the different type of a polynomial function. We know that how they are look like. It's our turn to graph them, sketch them, and make a polynomial function. Equation and graphs of polynomial function. First, we are starting with the easy one, the one that we know it from the past. Is a x by power of 3. For x by power of 3, if I'm sketching, if you remember from the past, the graph is gonna be 2, is gonna be 8. Oops. Sorry. Oops. It's not so easy sometimes working with the tablets. Okay. Fair enough. Look like enough to x by power of 3. Cubic function x by power of 3 is a shape like that. As you see, the degree here is 3 and the leading coefficient is positive. And it's passing from quadrant 3 going to quadrant 1. Has a 1 x-intercept and the y-intercept is 0 and 0. And x-intercept is 0 and 0 in that case. Now how about negative x by power of 3? Negative x by power of 3 is the same shape but is reflected to the y-axis. Degree again is 3, sign of leading coefficient is negative, and quadrant is passing quadrant 2 going to quadrant 4. 0 and 0 is your like x-intercept and y-intercept is 0 and 0. As you see, it's a degree 3. Degree 3 are going from the opposite direction from a quadrant to another quadrant. X by power of 3 is a parent of the cubic function, but not all of the cubic function having just one x-intercept. You saw before that the degree 3 minimum number of the x-intercept or roots is 1, but the maximum number of roots is 3. Then we have a situation that we can have a 3 x-intercepts. Then how is going to be the shape of those functions? Here I have a 2 example. First, I know that this example is hide a little bit like in my picture. Here first we are starting this example. Here it's an example. I know if I like to expand this one is going to be a degree of 3 because there's a 1x here multiplying by another x here and another x here is going to be x times x times x is going to be a degree 3. Let's see. Then technically I'm taking care of each part. X biggest exponent here, x biggest exponent here, and x. Then technically x by power of 3 is gonna be the biggest exponent or biggest term of this function. Then the degree for this function is 3. How about the sign of leading coefficient here? As you see, sign of leading coefficient here is positive. If degree is odd, leading coefficient is positive, I know that leading coefficient positive, it has to be end up at the top here. But degree is odd, then it's starting from opposite direction here. Then the quadrant is gonna be quadrant 3 going to quadrant 1. Now, main part, it's a what are the x-intercept? As you see here, for x-intercept, I can have a x equal by 0, or I can have a x equal by 2 equal by 0 means that x is equal by negative 2. Because it is my function, yeah? When I'm looking for x-intercept, I have to put each part equal by 0. Here I had a x, I put x equal by 0, then x plus 2 is equal by 0, and finally x minus 1 equal by 0. That is giving me x1. Then the roots or x-intercepts are gonna be 0, negative 2, and 1. How about y-intercept? Y-intercept means that x is equal by 0. If I plug x equal by 0 here, I can see that the y value is going to be 0. Also, whenever that you have in your x-intercept 0, you can do right away without thinking about y-intercept 0. Because X-intercept means that y is equal by 0. If y equal by 0 is giving you x is equal by 0, then opposite way is going to be work same thing. Now I'm going to put all of this information on this graph. I know that I'm going to start from here. I'm going to finish at here because quadrant 3 to quadrant 1. Now my x-intercept, one of them is a 0, one of them is a negative 2, and one of them is a 1. Then I'm going to pass these 3 points. Y-intercept is 0, okay, is that point. I'm going to pass this point to draw my graph. Let's start to do. It is my function. Starting from here, finishing here, and having this x-intercept. Good. Now, I'm just doing this graph a little bit smaller that you can. Now, you will start to do with this one. Write it down the equation. Start to do on piece of a paper, and I'm going to start after 30 seconds. Hopefully you did it. Right now we are doing together. See, how did I calculate? How did I find out what is the biggest or highest exponent? Here I have a negative before starting of equation. It's a negative 1. I'm just putting negative. From this bracket, I choose to write it down x. From this bracket, x because the highest degree, and this bracket x. If I multiply all of them together, I'm going to have a negative x by power of 3 that's representing highest degree of my function. Degree is 3. Sign of the leading coefficient is negative. Because degree is odd, I'm expecting opposite direction. And because sign of leading coefficient is negative, I'm expecting to finish here. And because they are odd degree, then it's going to be a start from here. Then roots is going to be the roots for each of these bracket. X minus 3 is equal by 0, x is 3, x plus 2 is equal by 0, negative 2, and x minus 1 is 1. I did these ones on mine. For y-intercept, here I didn't have a x-intercept 0. Then technically I had to calculate the y-intercept by myself. Then what I did, I plugged a 0 for each of them and I got negative 6. Now I'm gonna graph whatever that I have here. Here I have these 2 points. I have a point 3. I have a point negative 2. And I have a point 1. And for y-intercept, I'm assuming just here is negative 6. I'm going to pass this point. Let's connect the point that I have here. Oops. Maybe I have to start from here. This one's me, I did it, but it's not so nice. It has to be curve. You cannot do it as a, so sorry. You cannot connect them as a sharp line. It is a polynomial function. I'm sure that you can do easier and in a better format. And do not forget to put an arrow at the end because they are continuous function. Okay, hopefully that all of you could do these ones. I'm going for the next questions. It's a very nice question. I like it. These two questions. Let's see what are the another type of a cubic function I can have. As you see here, I have a x at the first bracket. Second bracket, yes, I have a x, but this x has exponent 2. Then technically, I have a x by power of 3. Again, it is a degree 3, positive leading coefficient. Then for sure the quadrant is going to be quadrant 3 to quadrant 1. How about roots? How about the x-intercept? As you see here, I can have a one root here, negative 2. The other root here is going to be 4. But this 4 has a order 2. You may ask what is the meaning of order. I'm gonna just write it on this side. See, when I have a x plus 2 equal by 0, x is equal by negative 2, and I'm done. It's a linear equation, and I got a one answer. But if I have a quadratic equation like that, equal by 0, technically is a x minus 4 is equal by 0. And x is equal by 4. I am gonna have a one answer. One answer for a quadratic equation. Means that it is in order 2. Order 2 is a like a bouncing point when we are graphing. You will see. Let's see here. If I'm calculating y-intercept, if I plug a 0, it's going to be 2 multiplied by 16 is going to be 32. Let's put everything together. Y, x, from here to here. And I have to pass this point. I have to pass this point. And it is a, I'm assuming, like I'm just putting two lines here. I'm just assuming here is 32. Let's see how am I gonna connect these lines. Here, 4 is for me a bouncing point because there is an order 2. Means that I'm gonna go reach it, but I'm not gonna pass. I'm gonna bounce, go up past this point, and this is gonna be my graph. 4 is gonna be your bouncing point. You are not gonna pass because there is an order 2. Same things when you had a x square. Y equal by x square, roots was 0, but technically you are bouncing at x equal by 0. Look at this question here. I have a negative x by power of 3. Let me change the color. As you see, degree is 3 again. Leading coefficient negative. Quadrant is gonna be quadrant 4 to quadrant 2. But as you see here, when I'm trying to find the x-intercept, I'm gonna have just one answer. X equal by negative 3. See, for a cubic function that I was expecting to have a 3 answer, I just got one answer, negative 3. This negative 3 is in order 3 because it's falsifying another two roots. For Y-intercept is negative 27. Let's see what is going to be the shape. Here, I'm going to do quadrant. Sorry, I made a mistake here. It's not a quadrant 4 to quadrant 2. It's a quadrant. The quadrants are correct, but the way that I wrote it down was not correct. Quadrant 2 is going to quadrant 4. I'm starting from here. I'm going to finish here. I'm going to pass negative 27 and negative 3. I'm sorry, negative 27. And I'm going to pass negative 3. Okay. I want to take you to this question. Look at there. Here I had a x by power of 3, degree 3. Here it passed 0. But as you see, it doesn't pass straightforward. It's passing with the curve. When we have an order 3, we are naming this one as a inflection point. It's passing with the curve. Let's see how am I gonna do the graph here. As you see here, I didn't pass. Look at this passing. From negative 2, I just passed. 4 is a bouncing point, and this point is an inflection point that is passing with the curve. Okay, hopefully that is understandable for you. I'm going for the overall for the cubic function. Have a hill and a valley in the middle. Their degree is 3. The maximum number of 0 or x-intercept for the cubic function is 3. If the lead coefficient is positive, the graph starts in the third quadrant and end in the first quadrant. If the leading coefficient is negative, the graph starts in second quadrant. Oops. Again, I know why this notepad is giving me a hard time. Okay, instead I'm gonna write it down just the 2. And it's gonna be finished at and it's ending at which quadrant? Fourth quadrant here. If the exponent of the variable or bracket is 1, like x plus 2, it's just as you see, it's just the passing. The curve will pass the x-intercept. But if the degree is 2 like that, do you see? If the exponent and the variable or bracket is a square like that, the curve will bounce on a x-intercept. And if the exponents and the variable or bracket is cubed, as you saw it before, the curve will be appear flatter and have a point of inflection, as I told you, is a inflection point at pass through the x-intercept. They are the main part for graphing the polynomial function. If the degree is 1 is passing, degree 2 is bouncing, and degree 3 is passing with the inflection or curve. Let's work on a quartic function. We are starting with the cubic function because you already learned linear and quadratic last year. Is a degree 3 and degree 4. Let's see what you can do for the first two questions. I'm giving you 1 minute time and then you can start. I'm going just to put an x and y axis here. Sorry. Okay. As you see, the degree here is 4. Yeah, it's easy to answer. It's a positive. Okay, degree is even. It's a positive. I know that it has to be finished on the top here. Degree is even. Then both hands are using the same direction. As you see, Q2 to Q1. How about roots or x-intercept? It's a 0. And y-intercept, I know that's going to be a 0. This function is going to be a look like quadratic function, but it's going to be skinnier than quadratic function. About the negative x4 is going to be same things. It's going to be open downward, but is skinnier than quadratic function. The reason is that it's a skinnier because, for example, if I plug a negative 2 in a quadratic function, I'm going to have a 4. But if I plug negative 2 in a quartic function, the answer is going to be 16. The values are higher and the answer is like the shape is getting skinnier. It is the overall of the quartic function. Let's see, based on whatever that you learn, how you can do these two questions. Degree is going to be 1, 2, 3, and 4. And sign of a leading coefficient is positive here. Then it's going to be quadrant 2 to quadrant 1. And the x-intercepts are going to be 2, 1, 3, and negative 3. And y-intercept, if I plug a x equal by 0, I'm going to have a 2 multiply, okay, it's a negative 8. I'm assuming here is negative 8. Same things that you did in a cubic function. Let's see if I can do this function. It is my cubic function, passing all of them, and make sure this y-intercept, maybe we had this example before that like when I was drawing, I put y-intercept as a maximum value or minimum value. In advanced function, we do not have this knowledge to know that where is the maximum or minimum value of the function. Then we are doing a rough graph. The graphs that we are doing, they are not an actual and exact graph. They are a rough graph that we are just following the x-intercept, y-intercept, and the end behavior. That's it. For this example, I prefer to give you a time that you can do it by yourself. I'm giving you 1 minute time that you can do it. Okay, let's see what did you do here. Here I have a negative x by power of 2, x by power of 2. Degree is gonna be 4. Sorry. Degree is gonna be 4, leading coefficient negative, then is gonna be q3 to q4. And x-intercepts are gonna be negative 2, but in order 2, and 3, same things, that one's in order 2 as well. Y-intercept, if I plug a 0, is gonna be 4 multiplied by 9 is gonna be negative 36. As I told you, is a rough graph, then it is the reason that, okay, negative 36, quadrant 3, going to quadrant 4, and I have a negative 2 in order 2, and I have a 3 in order 2. Order 2, if you remember, it's a bouncing point. We are not gonna pass, we are gonna just bounce. And I'm gonna put the arrow at the end to showing that it's going down. Hopefully that you got same answer. Let's see, how about these two questions? As you see, a degree 4 can be written down in so many different ways. It can be like as a 4 linear bracket. It can be as a 2 brackets, each of them by power of 2. And here you are seeing another way. 1 bracket power of 3, 1 bracket linear, or 1 bracket power of 2 and another 2 brackets of power of 1. Then I prefer to do this question, and you can follow. Degree is 4 for sure. Sign of leading coefficient is positive. Quadrant is gonna be quadrant 2 going to quadrant 1. Okay, x-intercept is gonna be negative 2 in order 3. And also I have a 1. Y-intercept is gonna be negative 8. Okay, it's here is negative 8, assuming it's a negative 2 is a order 3 and it is a 1, and I'm not forgetting to put a y and x here. I know when I'm passing negative 2, I have to show the inflection point. Assume that this one is past negative 8. It is the graph that I could do for this function. Let's see how we can do for this one. Degree, again, is 4. Sign of leading coefficient is positive. Quadrant is gonna be 2 to 1. X-intercept, there is a negative 1 in order 2. Order 2. Look like that again. This one is giving me a hard time. Do you know what am I gonna do? I'm gonna write it down in a short form. No way. I'm gonna write it down into the bracket 2. Okay. And then another ones are 2 and negative 3. And y-intercept is gonna be 1 multiplied by 3 multiplied by 2 is negative 6. No way. Let me one more time close and open the app. Look like that. I'm so sorry. Q1. This one's a order 2 and I have a 2 and negative 3. And as I remember, it was negative 6, yeah? X, Y. Okay, I have a negative 1 in order, oh, okay, Q2 to Q1. And I'm gonna pass 2. I'm gonna pass negative 3. And y-intercept is negative 6. Let's connect all of the points. I'm gonna start from that side maybe this time. When I'm passing 2, 2 is a normal point that I'm gonna pass. But negative 1 is an order 2 I'm not gonna pass. I'm gonna just bounce and go back. Okay. Let's make a conclusion and summary for the quartic functions. Let's see how many of these questions we can answer. Their degree for quartic function is 4. Their shape is similar to a quadratic or U-shaped. The maximum number of x-intercept is 4. We had this one before. And if the leading coefficient is positive, again this one's giving me a hard time. If the leading coefficient value in front of the bracket is positive, the curves open up and it's begin and ends in a quadrant what? If it's opening up, it's starting from Q2 going to Q1. If the leading coefficient is negative, the curves open down and it's gonna be Q3 to Q4. Note that if the variable or bracket has an exponent 1, the curve is gonna be, again, same things we are repeating. The curve pass x-intercept. If the variable or bracket, I'm so sorry, I know. Hoping to solve this problem until next session. If variable or bracket has an even exponent, the curve bouncing at x-intercept. The variable has an odd exponent greater than the 1. The curve passes through the x-intercept with a slight curve. Okay, you have all of the information that you need to graph any function that you like. Right now, any polynomial function. Let's try to do this question. The question is asking, graph this one and make sure that you are factor fully before graphing. I am starting with this function. It's a x4 and x. I can factor the function before going further. Function is gonna be x minus 2, x plus 2 for the first part, but because I have another x plus 2, then I can just write it an exponent 2 here. Degree of the function is 3, and the sign of leading coefficient is positive. Quadrant, for sure, if it's a positive, is going to be a start from here, and it's going to be finished here on the top. Then the quadrant is going to be Q3. X-intercepts are going to be 2, and negative 2 is going to be in order 2. And Y-intercept, if I plug it to 0, is going to be negative 8. I'm assuming negative 8 is here. X, Y. X-intercept is going to be 2 and negative 2. I have enough information to start to do. Negative 2 is in order 2, then it's going to be a bouncing point. It's going to be my graph. Let's do for the next question. There are a couple of questions here. I would like just to maybe go for the last one. You can do a screenshot from this page, do these 2 questions at home. You can stop the video because you can see the video later time. Then you can work on it and do it by yourself. Here, I want to do this question because the degree 6. Here I have a degree 1. I'm talking about the part D. Here, I have a degree 1, degree 2, then it's going to be degree 3, and finally, the biggest exponent is going to be x by power of 6. Degree is gonna be 6, leading coefficient positive. Degree is even. I know that it's gonna be same direction. It's gonna be a start from top, finish at 5. Then the quadrant is gonna be quadrant 2, going to quadrant 1. Roots is gonna be 0 for the first one. 2 is gonna be in order 2. And finally, negative 3 is gonna be in order 3. For y-intercept, as long as I have a 1, 0 as a x-intercept, I'm going to put this one 0 as well. Let's see how it's going to be the shape look like. 0, I have a 2, and I have a negative 3. Okay, I'm starting from this point, coming 2 is a degree 2, bouncing, 0 is a normal, and as you see, negative 3 was in order 3, and I try to make as much as I can a smooth curve to pass it. Yes, you draw a degree 6 polynomial function here. Folks, I would like just to leave these two questions for you. There's a 2 here. This one is already factored form. This one you need to factor it. Please factor and start to do these two questions by yourself. Plus, I'm hoping that you made a note or whatever, because I like just to go to the next slide too. Next slide has a more homework question. Doesn't matter McGraw-Hill or Nelson book, if you are following, they do not have that much homework for graphing the polynomial function. They do have, but as much as you do more homework question, you will be more successful. Then I have a more homework question for graphing here, that I am suggesting you to do these questions until the next session. Our next session is gonna be on Monday, same time, I believe so. And then we can go over the next lesson and learn more. Have a good day. Stay at home. Stay safe. Have a good day. Bye bye, and see you next week.